All right, we are live. Hello, everybody, and welcome to the stream. Hope everybody is doing well tonight. We are going to pick up where we left off on the last stream, plus some offline work that I've done. As you can see here, we're up and running, albeit we have some issues to work out. But before I get into that, I do want to just take a quick second and thank the supporters of the channel, starting with our elite partner, Javier Lazaran. Following behind them is our partners, Gaboli's Inc. and Matt Osgard. Those are the highest tiers of subscription over on YouTube memberships and Patreon, followed by our list of supporters you see here on the screen. They are a combination of the other tiers of Patreon, support on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me cover the cost of running this channel, things like hosting fees, software licenses, things of that nature. So thank you very much for that support. I really appreciate it. It means a lot to me, and yeah, definitely helps me out. And of course, I'd like to give a big thank you to all of the viewers, whether you're joining me here on live on the Twitch side or the YouTube side. We simulcast to both, or if you're just catching the VOD after the fact. Thank you guys very much for being here. I appreciate each and every one of you guys, because without you guys, this project and thus this channel would not exist. So thank you guys very much for being here. Psycode, good to see you. How are you? Pale Blue Zebra, good to see you as well. Welcome. All right, so as you can see here, we've got things up and running. I actually did a little bit of work over the weekend, just kind of trying to push this along a little bit in terms of getting things, going. And so there are still some issues with it. You can see in the reflection that's a little bit messed up. We've got a little bit of issues here with transparency sorting. So we have some things to work out, and that is basically what this stream is going to be about. Is just kind of stepping through those issues and solving them one by one. But for all intents and purposes, we are back up and running, right? So the major parts of the renderer have been put back together. The major parts of the scene have been put back together. There is a little bit more additional work we have to do around that, but we've made some pretty substantial headway, and we are going to continue on with that tonight. So just as a quick sort of agenda as to some of the things we're going to look at, aside from some of the I guess visual things that you may have noticed. If we look at the to-do, we actually have a couple of things here. So let's see. Move render code out of material system and into a material renderer. I've actually done that, and that was done mostly off stream. I can't remember. I think we might have started that on stream last time. But basically, that looks a little bit like this. So here's the header file. And so all of the structures that were sort of in part of the material system itself have all been moved over to here. So there's not structural change of a lot of it. It was just splitting out all of the render-specific logic, such as setting shader uniforms and things like that, splitting those out from the material system into a separate K-material renderer. And so that means that the material system itself is just responsible for managing materials, but not necessarily how they are rendered, right? That is split out to this, which makes it a lot easier to sort of wrap your head around and manage. Magette's good to see you. Welcome. True5 over on the YouTube side, hello. Wanted to thank you for your incredible teaching. I just got into the 5th video and it goes amazing. Awesome. I really appreciate that feedback. Thank you very much. We did switch away from the tutorial format eventually in that series and switch over to the live format here, which I think works a lot better. But I think the tutorial format worked for the beginning of it, but obviously, once you get past a certain point in a code base in terms of size, that doesn't really work anymore. But I'm glad it's helping you. And thank you for the feedback on that, and thank you for joining here live. Okay, so the renderer itself is not all that complicated. Like I said, most of it is just moving logic over from the material system over to here. And it's all of the, shader use, binding, setting UBO data, stuff like that, right? So it's all the rendering specific stuff of materials that's been split out to here. So most of this is already logic that you've already seen. It's just kind of moved at this point. And it makes it a little easier to manage separation of concerns and all that. So there's that. That was one thing that was kind of done off camera. So the commits for that are up. Let's see. So move scene to game code, game specific. I think we can actually mark this as done. It's code complete, or mostly code complete. There's still some issues we have to sort out with it, but I think we can mark it done. And we'll sort of sort some of those issues out tonight. Change scenes to use a single level of inheritance. Have a base entity that has properties, and then things that sort of come off of that. We had that actually in the last stream, so that's ready to go. Remove all references to scenes in the engine core runtime. So we have not done that yet. That's going to be something that we are going to do once we're done bug fixing. Refactor testbed project for the above changes. So that's basically going to be taking all of these changes here that we've made for the Illumina object and porting them over to testbed. So that's going to be probably something I'm going to mostly do offline, just because I don't think there's much value in doing it twice on camera. So that's that one. Remove some legacy systems. We still have to do that. We have to hoist the Overdrive project to its own repo. That's another thing I can do offline. But some of the things that we're going to look into are some of these bug fixes here, right? So these are bugs that have been reported on GitHub. And I'm hoping to kind of get to some of these, not necessarily in this order, but I'm hoping to get to some of these tonight and close them out. Specifically things like this one, right? That's a relatively low-hanging fruit. We should be able to solve that one pretty quickly. The Mac OS build script, that's not really something I'm going to be able to easily test on stream, I don't think. So same as i3WM. Again, that's going to be something we have to do off stream. Windows build script works as intended. We want to remove the PowerShell requirement from that. So I don't know that we'll do that this stream, but whenever I do get to it, we'll kind of go over where I landed on that. And then make a setup script that creates the clangd compile flags text files that is independent of the build process and can be run separately when the project is first cloned. So this goes a lot into when you first clone the project, especially if you're running it or you're opening up in Vim, since it heavily relies on those things for IntelliSense and error reporting. If those things aren't created, that's a problem, right? So that we might get to tonight. We'll see. But that's basically kind of some of the stuff that we want to fix, in addition to some of the bugs and to-dos and fix-me's and stuff with the general systems themselves. Let's see. Hey, OC, first-time chatter, welcome. Hope you're doing well. Apotham, good to see you. Hope you're doing well as well. Well as well, yeah. Awkward way of putting it, but you know what I mean. Okay. So, essentially, if we go back to debugging this really quickly, I just want to kind of take a look at some of the things that are going on and kind of fix them in terms of, bigger issues versus smaller issues, right? So right now, if you notice, it's a little hard to tell because we're not rendering our grid, but everything here is rendering at 0, 0, 0, right? Thank you for the follow. Appreciate that. And so if I hit, the WASD to move around, right? Because we're in world mode right now. The camera does move around, right? You can see a reflection issue there that we have to solve as well. So the camera moves around, but the mesh does not follow it, right? So there should be a transformation happening there that isn't happening. So that's one thing that we have to fix. Another thing that we have to fix is obviously the reflection bug, right? So we'll have to get to the bottom of that. And then also it looks like our transparent materials are not being sort of drawn correctly. So you'll notice here that we're not getting any artifacts over top of an opaque mesh, but we are getting artifacts over top of the water when it's drawn. And then if we actually move the camera down a little bit, it looks fine over the skybox too. So that's probably just a order of operations like draw thing. And then also I noticed that the shadow pass is not getting the transparent geometries being drawn. So we're getting the opaque ones, that's the sort of branchiness you're seeing there in the shadow pass, but we're not getting the leaves and stuff like that. So we've got lots of little things like that to fix. Was that Steve Brule? Yes, it was. Yep. So one of the things on the channel that's become a bit of a theme is we talk about dingus-oriented programming here, which is where I screw up code on stream live, which I do all the time. But, just kind of the term dingus gets thrown around a lot. So I have changed it so that anytime somebody follows, there's a message that appears that says, you've joined the dingus army. And then it has, Steve Brule coming up and saying, you dingus. So, yeah, that's what that's all about. All right. So, first thing I think I want to take a look at is actually not in material render. It's probably in Illumina main, where we are building up what we need to go ahead and render. Oh yeah, there's also one other bug that I want to fix. Let me bring this up. There's one thing I'm hoping to fix as well. So whenever you bring up the command console, you can see here that you've got the cursor here, and that moves as you type and whatnot. But you can't actually see the text, and for some reason this texture looks really weird. And so we need to fix that as well. Because I added a couple of console commands just for kind of convenience to be able to set the camera position and rotation. Yeah, dingus, exactly. Yep. Love some Brule's rules. Yeah, Steve Brule is awesome. John C. Reilly is incredibly good at playing that character, for sure. Okay, so let's go to prepare frame. So this is where we build up all of the structures that we pass over to the renderer, right? So let's see. We're gonna. Oh yeah, we don't have point lights figured out also, so we need to figure that out as well. But I kind of want to address some of the bugs first before we actually continue on. So essentially, we have our shadow pass here. So everything within those two brackets is for the shadow pass. Everything between this bracket and the end is for the forward pass. And then we have the world debug pass, which isn't actually doing much at the moment. And then we have the editor gizmo pass, which also isn't doing much at the moment because it's not actually being fed anything from the scene. And then, of course, we also have the standard UI pass. So we're going to be touching probably a few of those tonight just to kind of sort out some issues. But what I want to look at is actually in the shadow pass. So I think this one might be a relatively low-hanging fruit. So we have converted all of the passes to use the new scene functions that we looked at in the last stream. the last couple streams rather, where we actually set up the data in the format that the renderer expects. Let's see. We have, for example, when we go over each individual cascade, let's see, right here. So here is where we actually request all of the render data for opaque materials, right? And so we used to have this sort of long bit of code that took all of the geometries out of the old scene, and then we had to sort of sort them and split them up between opaque and transparent in the game code, in the actual game code, right? We don't have to do that anymore. The only thing we have to do is we say we want to get the opaque geometry just by passing a flag here of none, and then we call get static mesh render data. That returns to us a array of these structures that contains materials split by, or I should say geometries split up by material, right? So each material has a list of geometries. Now for the shadow pass, an opaque materials, they can all be grouped together. So we do have a little bit of specialized logic for that. All we do is we build up that list here. However, for transparent, we don't actually have that. We don't actually have to do that. We can actually use this as is, right? So we can say render data, shadow data, and then we can fill out our transparent geometries by material right here. And I think what the issue is we actually have a count up here that we're taking when we call get static mesh render data with the transparent bit. We're saving that off, and we're using that down here to get a count of how many meshes we're actually rendering. But I don't think we should be doing that. We should be taking render data, shadow data, transparent, geometries by material count. We should be passing that in and setting it, because I suspect that is the reason that we are not rendering transparent geometries in the shadow pass. So I'm going to go ahead and build this, and we'll run it and see where we actually wind up. Yes. Okay. So that is it exactly. So you see here now we have the shadows being rendered from the leaves up here. So that issue is fixed. That is awesome. Okay. So let me just catch up on some chat here. Thanks for the nice greeting. Happy to be here. Awesome. Happy to have you. Singy, good to see you as well. How are you doing? Became an expert casually in watching you and others for a decade. Your time is valuable and appreciated. I appreciate that. Yeah. Hopefully this is of use to some folks, right? That's really the goal here. Spiro, I'm late, but I'm here in all caps. Yes, you are. Thank you, brother. For those of you who don't know who Spiro is on the Twitch side, he's a good friend of mine. He always tries to show up on my streams. He's really good about it. Let me give him a shout out. So he is another developer here on Twitch. He is always doing interesting things on his channel. He goes over tech news, which is usually about things that get hacked and stuff like that, or interesting stuff that he finds about AI and how terrible it is. But also, he also is making a game where his engine is written in C, and he is using the HTML DOM as his renderer. So no graphics acceleration or anything. He's basically compiling his engine to WASM, and then he is rendering that as via the DOM, rather. So it's super interesting. So I highly recommend you guys check him out. Thank you for the follow. I appreciate that. All right. It's what I'm trying to learn right now, and I need a CPU-only renderer for a software engine. Nice. Yeah. A software renderer is something that's like been on my bucket list of things to write from scratch. I just don't have the time currently. Hopefully one day. Might even wind up being a series on the channel. VW5. Hello, how's it going? Currently using OpenGL, and I don't want to have NVIDIA pop-ups just from font and images. Yeah, I mean, I get that. Although I was as rendering APIs go, OpenGL is pretty straightforward. So you can't really go wrong with that. All right. Let's also take a look at, I think, where was that list? Was it at the top of... I think it might have been at the top of the material renderer page. Yeah, okay. So we have a bit of a to-do list here as well. So let's see, remove multiple view positions per draw index, no longer required. Okay, so we got rid of that. Move over all shader data. We did that. Simplify the API. So we did that. Material base creation, registers. Okay, so this is actually something that we probably ought to go over. So whenever a new material is created, it is registered with the renderer, right? So we actually have a register and unregistered base, and then register and unregistered instance, and that is what creates the underlying resources for that. So that is something that new that we have added. Sergeant Pepper with a raid of 13s. Thank you so much for the raid. What did you get up to on stream? Let me see if I can... if it'll let me yet. Yeah, it's going to make me wait. Okay. Oh, Spiro, you already did it. All right, cool. So yeah, for those of you who don't know, Sergeant Pepper is also a good friend of mine. He does a lot of programming streams here on Twitch as well. And he just rated us, so welcome, raiders. You asked, so here it comes. Lucky number 13, yep. Working on my Rust API for my Godot game in Rust. Rust, yeah, I know. That's curse words around here, buddy. No, I'm just kidding. That's cool, man. I know you're big into that, and I know you've made some pretty cool stuff with that, so I don't have an issue there, you know. We joke about it a lot on stream, but I'm not really serious about any of it. Thank you for the follow. I appreciate that. Yeah, so for those of you who are new here, we are making a game engine from scratch. It's called the Kohi game engine. We are writing that in C, using Vulkan as our initial rendering backend. And I say initial because we have plans to support Direct 3D as well as Metal in the future. It is cross-platform, available on Windows, Linux, and Mac OS at the moment, with other platforms planned for the future. It is open source and free, so it is freely available on GitHub. It is Apache 2.0 license, which basically means you can use it for personal or commercial projects. I do not care. The only thing that I ask is that if you use it, you say you used it, right? That's literally it. And as far as that goes, you know, this is kind of designed to be an educational resource. So it's a way to build a game engine. It's not the only way to build a game engine. It's not even sometimes the right way to build a game engine. We try a lot of things via experimentation on this stream, and we do deep dives into what works, what doesn't work, and why. And so we've tried a lot of stuff over the years. We're trying some new things now, actually, or we're kind of switching away from some things that worked but not good enough. So that's just kind of an example of some of the things that we do, right? So as an educational resource, I believe that this stuff should not be paywalled. So nothing with the game engine will ever be paywalled in any way, shape, or form. There'll never be any royalties or licensing fees of any kind ever. It will always be free and open source. That is true for the engine. That is not necessarily true for the games I'm making with it. At least not until a little while after they've been released. So the plan is here that we are making a game and an engine to host that game from scratch, and we are going to take it all the way to release on Steam at a minimum. So that is that. The site you're looking at right here, I've dropped a link in chat. There's a couple of other links on here on our YouTube channel, the Twitch channel. I've got a Discord server with a little over 1,000 people on it now, linked to the GitHub. I don't have any sponsors or anything, just you guys, so there's a link there to my Patreon if you're interested. And yeah, that's about it as far as that goes. The type of game that we're building is a 3D isometric action RPG. We've done a little bit of exploration in terms of how we're going to set up the lore for that, some of the background lore, some basic world building through some mapping, but we still have a lot of design work to do. So we're at the point now where we're sort of we have the engine almost where we want it to start actually being able to develop the game. There's just a few more things we need to do. And we're going to be kind of switching back and forth between the games. So any code references you see to Illumina, that is a reference to the game. Any references you see to Kohi, that's a reference to the engine. So the game is called Shadows of Illumina, but the sort of internal code name is just Illumina, right? I hope that makes sense. Okay. Rust is a perfectly serviceable language and one of the few out there that could currently be a legit C++ competitor. No shade to C or C++ programmers. Yeah, I mean, to each their own, right? I've looked into it enough to know that I don't want to use it, but at some points I do actually have I did actually. I think it expired actually. I had a deal with chat that if I hit 100,000 subscribers on YouTube before the end of the year last year, that I was going to write a Vulkan render in Rust, but we didn't hit that. So, however, if we do hit 1 million subscribers on my YouTube channel, I will write a Vulkan renderer in assembly, and that one doesn't expire. So there's that. Okay. If I was at gunpoint forced to switch from C, C++ to anything else, I'd probably do Zig or Odin. I feel the same, Magetz. I feel like Odin would be the one I would choose, probably. Okay, let's see. Let me catch up over here on the other side. When you decide to create the world's first valid multi-contextual engine and you include Raylib, SFML, STL3, and OpenGL into a multi-context software engine and reuse the context. Jeez. That sounds like a nightmare to manage. Yeah. Kohi. Thought it was the Koi engine. Yeah, no, it's Kohi, as in the Japanese pronunciation of coffee. Why do you use ZSH over Bash? Preference. Let's see. Okay.
You dingus.
Raw. Thank you for the follow. Appreciate that. Raw shell speed. Bash is marginally faster at startup. If you run vanilla.interactive, interactive workflow speed and ZSH wins when you factor in auto suggestions, completions, smart history, less keystrokes. Yeah, exactly. Yep. Preference. Let's see. Hi. Should I download 0.11 for Kohi, the latest updates, including modifications made in the development of Luna? So here's the thing, right? 0.11 is not ready. That's the current version that we are targeting, right? So I would say hold off on downloading that, right? Because you're going to get a half-working thing. Because we have not ported the testbed project to work with all the changes we've made, right? I'm sort of test driving it in the Illumina project, and then I'm going to port those changes over to the testbed project. And that's going to be kind of the template we're going to use. So I kind of want to iron out all of the issues here, and then I'll port that over to testbed, and we'll go from there. But yeah, I would not use 0.11 yet. It's our current working version, and it's nowhere near ready. Since we've talked about languages, have you heard of Jai? Yes, I have. I have not tried it yet, though. Namely because it is not, released officially. And also, I don't know if like it's going to be public release or something like that, but I'd like to try it, but like it's not public yet, right? So like if he decides he doesn't want to do that at some point, then you're kind of screwed, right? So yeah, I have my reservations about it. I think it's awesome, but yeah, I don't think I'm certainly not going to change this code base to it, right? This is pushing 80,000 lines of code. I'm not going to be converting this to that. Problem I have with Rust is its complexity. It feels too much like playing a puzzle game as opposed to programming. Yeah, my issue is that you're always fighting the borrow checker, right? And there are things I don't want to have to fight to write what I need to write. Now again, that might be a skill issue, but still. I understand that choice from a what language would I love to use perspective, but from the perspective of having a language that's somewhat mature and has enough market penetration that it's not going anywhere in the next decade, I think Rust wins over Zig and Odin currently. As far as market penetration, I would agree with you on that. Yeah. It's in closed beta, unfortunately, yes. Yeah, Jai is in closed beta, yeah. So it's like I could email him, right, and he might let me use it. I don't know. He rated me the other day, last week. So maybe he knows who I am at this point. I don't know. But like I don't want to convert my entire code base to it, right? So one of these years I will try it, just not now, probably. All right. What were your reasons for preferring C over Rust? I've been using C/C++ a lot longer. C doesn't try to like slap me for using memory the way that I want to use memory. Compilation speed's a huge one, right? C is infinitely faster in terms of compilation speed than C++. And again, in Rust, right? So that's another one. Incremental turnaround time is huge. Yeah, so I guess that kind of answers that. I like C syntax more, but the problem I have with it is that you don't necessarily have accessible feature-rich packages. See, I don't use packages at all, so that's not an issue for me. I also don't use 90% or 99% of the features in C++. Like if I were to switch to the C++ compiler, the only two features I would use would be constant expressions and operator overloads for math libraries, and that's it. I have no use for like the OOP classes and overloads and templates and all that crap. I don't have any use for it. Thank you for following. Appreciate that. I don't have the skill plus time to create and maintain some lib like fast API in C. I mean, once you get used to C, it's really not that bad. It's so much of a simpler language than C++. Yeah. So, yeah, it really depends on what you're doing, right? Functional programmer. Yeah, I don't know that I'd call myself a functional programmer because like what I'm doing here is not pure functional programming, right? It's kind of use the right pattern for the job, right? Use the right type of programming for the job. Use the right tool for the job is what I'm trying to say. If functional makes sense, use functional. If imperative makes sense or procedural makes sense, use that. At the moment, working on a back end, I'd like to code it in C and learn it that way, but I just don't know how I'd replace the easy Python stuff. I mean, you got to rip off the Band-Aid, right? I have found, and the thing I suggest on this channel all the time, if you want to learn C and get really good at it, write a string processing library, right? Take one of those higher level languages like Python or something, or Lua, right? Re-implement all of the sort of string functions that come with higher level languages like that in C. By the time you do that, you'll be good with the language, for sure. C is really easy to learn but hard to master. You are not kidding about that. I still don't consider myself a master of C. Can you achieve the same OOP power that C++ can do in C? I mean, if you really wanted to, but why? Imperative is the king, everyone else bows. Yeah. I mean, again, though, there's no one size fits all, right? There are situations where OOP makes sense. There are situations where imperative makes sense. There are situations where functional makes sense. Like, just use the right tool for the right job, right? I would argue that more often than not, OOP gets in the way. But anyway, I don't want to go down that rabbit hole again. We've done that a lot on stream. I would rip off the Band-Aid, but projects like PyTorch, FastAPI, etc. have hundreds of thousands of lines that I just can't do as a requisite to a project. Yeah, but the thing is, like, once you write those libraries, like, there are portions of, even from this engine, that I wrote years ago that I've ported from other projects, like all the my math functions and stuff like that. Like, I figured that out once. And I, re-explained them and sort of re-implemented them on stream. But yeah, like, that's kind of a thing that you just carry from project to project. Complex hierarchical systems only. OOP is only good in specific implementations. Your core framework should always be functional and static. It's a tiny kernel. I agree with that. Yep. Just like how using functions isn't functional inherently, using objects isn't OOP inherently. Yes, exactly. And people are like, oh, if you have a whole bunch of functions where you pass in pointers to structs and stuff like that, then you're doing OOP. No, not necessarily. There might be some overlap or some things that maybe line up with OOP principles, right? Or, a single OOP principle. But, like, that doesn't inherently make it OOP. I'm using Odin because C scares me. So here's the thing. If you learn C and you get good with C, no other language out there will scare you. Except maybe Haskell. But even that's, like, not the end of the world. All right. Where even was I? I'm trying to remember now. Functional programming is when you use any functions at all. Like, the whole thing about functional programming is it's not supposed to have side effects, right? Functions aren't supposed to have side effects. You take data in and you return data, but it's not supposed to have side effects on any sort of state or anything like that. That's the whole idea. Which, we've done some of that here, where it makes sense, but it doesn't always make sense for everything. Sometimes, again, like OOP, like if you try to make your entire code base, especially for something as complex as a game engine, if you try and make your entire code base and you just, like, everything, when you have a hammer, everything becomes a nail type of thing. If you try to apply that same principle across the entire code base, chances are it's going to get in your way in some places. Learned C and C++ many years ago. Haskell still scares me a bit. Yeah. I mean, that's understandable. That's why I was saying maybe on that one, right? Can maybe cobble together stuff in C. Haven't tried in a while. Might try at some point to make something, as knowing C would probably be good on my resume. Absolutely. Yep. And people like to say C/C++ as if they're the same thing, but they are not. All right. Let's see. What do we have up here? So let's see. We got rid of... Thank you for the follow. Appreciate that. Okay, we already got material registration, so that's done. Material instance registration, that's done. Set properties instead of uniforms where it makes sense. Yeah, that's mostly done. Move all directional light properties to global instead of group and shaders. That's done. Directional light should be set once per frame. That's done. Camera lights should be... or point lights should be set per draw based on the closest lights in the scene. Okay, so that one we have to do. And then we have, let's see, material system prepare frame, apply instance. All of this has been done. That's just porting the material system stuff to the material renderer. So out of all that stuff that we had, this is what we have left to do for the K material renderer, which we've actually plumbed in a lot of this stuff. Most of this work is actually going to be in the scene, believe it or not. What I want to do is, I think in Illumina scene, we have something. We have point lights in here. Did I actually make a way to actually query for that? We have add, which is good. So we can get the point lights entities added. But we don't actually have, okay, we don't actually have a way to sort of access that. So we need a way to query it, essentially. So I guess we'll go ahead and, let's see, what is this? Deserialize. So we already have that. We can actually load it. We just can't actually get it out of the scene yet. So I guess let's go ahead and grab that. Let's see. I guess I could put it probably after this guy. Let's go into the header file. We'll do, let's see. Do we actually have, I thought we had some point light, K point light render data. There it is. So K point light render data. And this is going to be sort of a scene-wide query as to all the lights in the scene. So there's two parts of this, right? So there's Illumina scene get all point lights, right? And this one is going to be pretty straightforward. So it's struct Illumina scene. All right, we'll have a U32 flags. I'm not sure we're going to need it, but at least we'll get it in there. And then we'll have a U16 out point light count. Whoops, point light count. And so essentially what this will do is it'll return a array of all of the lights in a scene. And it will do that. Let's see. It'll get all the lights and the count. Okay, yeah, that should be fine. I was trying to think if we needed a frame data to be passed in, but I don't think we do. So let's go in here. And we'll go ahead and just implement this function here. So in here, we'll basically just do if scene, and we'll also say out point light count. Then we'll do some stuff. Otherwise, return false, or return 0 rather. Here we'll do a K point light render data, an array, right? And we'll say out lights, and then we'll do return out lights, right? And then also, before we return in the sort of error condition, we'll do, well, actually, I guess in that case, this checks for both out point light count and scene. So maybe we ought to split those up. Yeah, I think I'm going to split those up. So also if out point light count, then we'll do this, right? And here we'll set, out point light count is equal to some number, and then return. Otherwise, here we'll set that to 0, and then if we don't have scene, we won't bother setting it at all, I guess. So let's see. I guess what we probably ought to do, we do have a maximum number of lights, right? So the max global point lights that we're going to support in our render is 64. And I think that's more than enough point lights, right? We don't really need that many point lights at once. If we do need more lighting than that, then we need to really kind of rethink what we're doing, right? I really don't think that that's going to be an issue. However, the max number of point lights we can have bound at once is 8, right? And that is bound to a single draw. So the idea is this is how many we can have in the scene, and this is how many can be bound to a single draw. So a single draw being a single static mesh, or a single terrain chunk or something like that. And so I think 8 is more than enough right there, right? Because we can actually use the scene to say, just grab the 8 most closest lights to wherever this is. And we'll have more efficient ways to look that up in the future. For now, we're basically just going to do a quick radius check to see, is the is the light within range where it could actually affect what we're trying to draw, and go from there. Let's see. Need to distinguish between syntax and the computational model that the compiler handles. There are more important differences between C and C++, even though C++ supports most of the syntax in C. Yes, I would agree with that. First time chatter, welcome, by the way. Never refer to them as C/C++, or worse, C/C++/C#. C# is basically Java. So I don't know, I don't know that I've ever seen somebody's resume that says C/C++/C#, but I'd probably bin it if I did see that. Honestly, if I took a job where C or C++ was the bulk of my work, it would take me a while to get back up to speed with them. Haven't done much with them since 2002. That's fair. I don't think it would take you all that long, though, if you've used it at a decent amount. Seen it on job postings, maybe not on a resume. Yeah, so on job postings, I kind of overlooked that a little bit, because usually the people posting those jobs sent one single email to a software engineer in the company, and the software engineer just basically said, well, these are the things that we're looking for, and they just basically combine them however they think, because they don't actually know. Generally somebody in HR is not going to know the difference between C or C++ or C#. They think they're all kind of the same thing, different flavors of the same thing. Yeah, never heard somebody say that, but I would be ignoring that person. Yeah, as an applicant, absolutely. But on a job posting, yeah, it's usually HR people that aren't necessarily, aware of the differences between those. Let's see. Kotlin is better than Java. I can't speak to that because I've never tried Kotlin. All right. So I think what I'm going to do at this point is I'm going to do scene point lights, right? And we're going to do a length on that. So darray length. And we're just going to do this the really stupid way. We're going to say if, actually we'll do, I guess, U16, or actually it could be U8 length is equal to that. And then we can say if U8 length, or length rather, if length is less than this guy, then we'll just go ahead and move over the entire array, right? So I guess, actually, let's do this instead. So we don't have to have this sort of branch in here because that's kind of annoying. Let's do a k-min, right? And we'll take the d-array length, but then we'll also take, we'll also take this. Right, so we'll take the minimum between those two. And we'll call that count. Right? This, let's see. So let's think about this for a second. This is bleating because we don't have this file over here included. But I don't know that I want the material render to be included in the scene, right? I don't think that's quite necessary. So I tend to think we should probably actually hoist these out of here and put that, well, wait a minute. Yeah, I suppose we could put them in renderer types. Do we have that? Do we have? No, we don't have renderer types. But I think that would make a lot more sense there. Yeah, let's do that. Let's go to renderer types. And I'm going to put that here. All right. And then over here, I'm going to put, I guess we do have that indirectly included. So there we go. All right. So we'll take the min between those two, right, so that we don't overflow this. And then we will do a, I guess we could just bring this down here. We can say outlights equals, and then we'll do k-array, k-alloc type c-array. And all we'll do is, let's see, type is going to be k point light render data, and the count is just going to be count. And then we have k copy type c-array, which is a new thing that I added. I'll show you what that does here in just a second. So we want outlights to be the target of that. The source is going to be scene point lights. The type is going to be k point light render data, and then we are going to have count. Now, actually, that's not going to work. So ignore that. We're going to have to loop it because I forgot we are compressing some of this data a little bit when it goes over to the renderer. So we actually have to handle this manually, which is not a huge deal. So we'll do u8 I equals 0, I is less than count plus plus I. And we'll do, we'll just do point light entity E is equal to the address of scene point lights sub I. And then we want our target, which is going to be k point light render data. So we'll just call that RD, and then that will be equal to the address of outlights sub I. Right, and then we'll just do RD, and color is a vector 3, right? It's a color 3. So that just means that we need to take the entity's color, which is, I guess I did split them out here. I didn't think I did. I guess I must have. All right. Might be a straight copy then. RD quadratic equals E quadratic. RD linear equals E linear. Oops. And RD position. Okay, so position is going to be, notice we don't have position here, right? So we're going to have to derive that from the actual transform. And thankfully, as far as lights are concerned, we don't have to worry about scale. We don't have to worry about rotation as far as point lights go, right? They're irrelevant. But what we do have to do is we have to say E base transform, right? And then we need to do K transform position get, right? Pass that there. And that will be our vector 3 that we're looking for. So RD position is equal to that, right? Okay. I think that should do it, right? So we basically just go through, copy all that data as required. I think that's just the 4 fields we need. Yep. Okay. And then we return the array. Pretty straightforward stuff, I think. Okay, so we have this here. Now we need to actually take the aluminum main, and we need to actually pass, well, we need to query it first and then pass that in through all of our sort of render passes. So I'm actually going to go up here to the top, and I think we had somewhere here. Here's the directional lights. Let's see. So we're going to get the point lights here. So K point light render data, and this is going to be point lights is equal to Illumina scene get all point lights, right? So we'll do current scene there. Flags is just going to be 0, and then we also need a count for that. So say U16 point light counts. We'll default that to 0, and we'll say the address of point light count, right? So we'll have those for wherever we need it in our passes, and then we don't need it for our shadow pass, so we can skip that. Our forward pass, however, is going to need it. So our forward pass, let's see, we have skybox. Let's see, where do we put, here we go. So our lighting, right? So let me make sure I'm not coding behind my head, which I would have been. All right. So render data, let's see, forward data. Do we not have, I don't think we actually have anywhere to store our point light data in here. Okay, we're probably gonna have to add that. Not a big deal. We do have a directional light, right? So let's go to definition on that. Yeah, okay. So we'll do a U16 point light count. And we'll do a K point light render data point lights, right? And we're just going to do, oops, point light counts is equal to point light counts, and render data forward data point lights is going to be equal to point lights. Now, the problem with the way that we've done this, and this is what I was kind of going back and forth in my head earlier, is that we have created this using sort of our standard allocation routines versus using our frame allocator. And I think we really ought to use our frame allocator here. And for those of you who aren't aware, our frame allocator is basically our, it's a linear allocator that basically just has a block of memory, and we move a pointer forward in that. And that is for allocations that need to happen within a frame. So there's very little overhead in getting that memory, unlike your typical allocation routines that have to go through under the hood, like a linked list and all that other stuff, and a free list, essentially. So we actually have one that's very fast, that basically gets reset every frame, and that's our frame allocator. So we want struct, or I guess we could just do p frame data, or actually it's just going to be frame data, pointer p frame data, right? That's kind of a standard thing that we've added into a lot of our functions, right? So that's going to be, did I put that? Let's see, I put that before flags. Okay. So we do struct frame data, p frame data, right? And so now we can actually use that allocator to go ahead and create this instead of doing it this way, right? So what we'll do is p frame data allocator allocate, right? And then we'll just need to do a size of, sort of the older school way of doing it, if you will. So size of that struct times the count, and that will give us that allocation that we need. Since it's being called in the context of a frame, that's perfectly acceptable to do. Let's see, does this require the struct? No, it doesn't. Oh, did I add it to the wrong one like a dingus? I might have. Yep, I did. Wait. This one. Right? Did I do that? Get water plane render data. Water plane render data. Did that have one as well? Yes, it did. What did I do here? Okay, I think I figured it out. All right. Oh, and then this one needs to have get spawn points. That one is just standard. That does not have to happen every frame. So that one does not need pre-frame data. I think I've got that figured out now. Classic example of dingus-oriented programming when I do stupid stuff and then it takes me a minute to figure it out. Kotlin is pretty good. Definitely better than Java. Okay. Better than Java is pretty low bar. Yeah, depends, right? Luna Moon, good to see you. How are you? Ruche, thank you for the coffee emote. That's the high one. Yeah, I thought so. Thank you for the follow, by the way. Appreciate that. Let's see. Oh, I've got a bunch of messages over here. Let me see. So where is the part? Wait, so where is the not pure functional part? Besides your function pointers, which aren't inherently, I'm not seeing anything not functional about this code. I mean, okay, so this isn't directly modifying like anything, I don't think. These are all sort of, these are relatively pure functions, right? They just kind of examine the scene. Like I could turn this into a constant, and in fact I might actually do that. These are actually all pure, but there are other ones. Let's see, that do have side effects. Like this one, for example, add audio emitter, right? So this directly modifies the scene, where we add a new entity to it, right? So this, any of these add functions basically add something to the scene's overall state. So they definitely do exist in here. Is it functional? No, I would say no. But is it oop? I would also say no. Java's good if you ignore all the bad things. I mean, aside from that, though.
You dingus.
Thank you for the follow. Appreciate that. Welcome. Okay, so we have get all point lights. Oh, I think we need in the main function. We need to pass our P frame data. Okay, so we have our points, our point lights. What was that note? Okay, so that should be fine. All right, so now in the forward pass, we go ahead and we set the point light count and the point lights on the forward pass to this, right? So we essentially are keeping hold of that that data, right? We do that every frame, so I think that's perfectly fine, right? Because we can add or remove point lights, or the the status of them can change, the light color can change, all that stuff. So we requery and we get that every single frame. I think that's fine. So we put that. I think we're going to put that and leave it in the forward data, right? I don't think we need to actually replicate this anywhere else. Nothing else needs the lighting data except for the forward data, the forward render pass data. However, we are going to have to fix something where we essentially we have to get a list of indices into this array. This array, right? Here. We have to essentially index into this array to tell us what lights actually should be used, right? And the trick about that is we're actually going to have to do a little bit of scene logic in order to get that to happen. So whenever we have this opaque meshes by material or transparent meshes by material, these are the same struct. So if we go into here and we have our Illumina material render data, right? So this is all of the geometries that are associated with this material, right? So if we go into the geometry render data, this is actually where we're going to wind up putting that, right? So we have the material instance here, the model matrix. It makes sense for that lighting information to be here. So for right now, I'm not going to pay attention to like struct packing or anything like that. We're gonna handle that later once we figure a lot of this stuff out, right? So we're going to say point light count, and we're going to do, I guess actually, technically, I didn't need to delete that whole thing. Just needs to be a U8, right? Because our maximum point lights that can be bound, I guess we should call this maybe bound point light count. That number maxes out at 8 anyways, right? So if I had a smaller integer type, I would use it instead. But anyways, so we have that, and then we have U index or U8, and it's going to be bound point lights, and I could dynamically allocate this, right? But I don't think I'm going to. I think I'm going to do max. What was it? Was it renderer types? Yeah, this one. Max bound point lights, right? So we're going to grab that and we're going to put that in here, right? It's only 8 of them anyways, so it's kind of a small thing here, right? So the idea here is that, this way we don't have to worry about every time we are setting one of these things up, dynamically allocating something here and fragmenting the memory that much further. We can just use this, and then use the count to actually determine how many loops we have, right? Let's see. Definitely doing imperative programming. It's very common to see. Yep. Let me see. If you call functions directly, that's different from heap allocated operators, like your getter, setter. Is your state static and everything, or is everything managed? It's not oop, but the function part suggests you call everything by pointer. So we call some things, like our scene is done with pointers, right? Because we don't have a lot of scenes, right? We generally work with one scene at a time. But other objects, such, and I use the term objects loosely, other, I should say, resources, things like textures, audio emitters, things like that. Those are all done with numeric handles instead of pointers. And there's an internal like resource array that points to. Entities are kind of represented the same way, external to that particular system. So, all right. Let's see. Bolovo Doce. First time chatter, welcome. Hello. Question is, how does one get into building a game engine? Been a developer for 10 plus years, but never knew what everything that is to put into one. Yeah, that's fair enough, right? So, generally speaking, like, there's a lot of different things that you have to understand and know, but you can learn those along the way, right? You don't have to necessarily... My biggest advice about writing game engines is don't be afraid to throw away your code, right? Especially when you're learning. Because you're going to write stuff and you're going to think it's awesome, and then 2 months later you're going to be like, oh crap, this design doesn't work, right? And that still happens to me. But what I usually say is, start off writing a renderer so that you've got some visual feedback. Start off with like something like OpenGL, because it's a little easier to kind of hit the ground running with that. Learn the concepts of graphics programming, the concepts of linear algebra and the things that you're going to need to power all that stuff. Learn all that stuff. And then once you get past that point of having a renderer, start to build the other systems around it. One thing that I always recommend is right back here on my shelf is this book, which is Game Engine Architecture by Jason Gregory, right? This is the 3rd edition. It's a fantastic book for an overview of game engines, right? So he's a developer at Naughty Dog, and he's maintained this book over the years. I'm hoping he kind of releases a 4th edition sometime soon, but the 3rd edition is the newest one as far as I'm aware. But this is a fantastic book. It gives you an overview of all of the different systems that can go into a game engine and how they should interact with one another. And it also gives a little bit of a primer on some things like memory management and other stuff in here that's kind of useful. So I always say start with that one. That's a really good book to kind of get you started. It's a chunky book, right? It's at least 2 C's thick, maybe 3. But I promise it's a good read. I've read it several times, right? And that's going to be a theme. That's a running theme on this channel that I talk about a lot of things. Books like that, you generally read multiple times. When you go to learn OpenGL or you go to learn Vulkan, once you move on to Vulkan from OpenGL, you're going to want to read that spec multiple times. I still read it top to bottom every once in a while because that's the only way you're ever going to understand it. There's no real shortcuts to this stuff. There's only getting through it, right? But yeah, that's a really good place to start because it'll kind of give you a high-level bird's eye view of like all the different stuff that goes into making a game engine. OpenGL is deprecated. How about start learning by using I assume you mean STL GPU. So I would not start there, and here's the reason why. STL is awesome, right? It's a fantastic library, and I think has a lot of good use cases. However, it abstracts a lot of stuff from you that I think if you're really wanting to get into game engine development is going to do you a disservice, right? It's really stuff that you kind of want. You want to be interacting with OpenGL or Vulkan directly. You don't want to kind of be working with somebody else's abstraction on top of that, right? So I generally recommend against that stuff when you're first starting. Roll that stuff with as few libraries as you can possibly get away with, because you don't want to be learning libraries. You want to be learning, the concepts of graphics programming and how to sort of get in there and roll your own raw, WebGL or not WebGL, OpenGL or DirectX or Vulkan renderer, right? Although WebGL, I guess, is an option too, but yeah. Thank you for the follow, by the way. Appreciate that. Game engines used to take 8 years to build. With AI, cut that down ×4 and reclaim my educational downtime. So that's another thing I would caution, though, if you're really new at this stuff and you're learning, don't use AI to replace critical thinking and problem solving. The minute you start going down there, like it's just like a physical muscle that you don't use all the time, right? Like if you quit using it, it's going to atrophy. Your brain is the same way, right? You need to exercise that critical thinking and problem solving on a regular basis, or you're going to get bad at it. So be careful with the use of AI because you don't want to outsource your critical thinking and problem solving with that. I would say learn without that stuff. Use it as a tool to maybe get you further for things like maybe writing unit tests or something like that, right? But I would not use it for writing any production code or any sort of code that you're trying to learn how something works, other than maybe having it describe the concepts, the high level concepts to you about something. But as far as the code generation goes, I've not really seen a whole lot of code that I would ever use in production generated by AI. Nothing wrong with raw OpenGL. Exactly. Yep. Yeah. OpenGL. So OpenGL is not going anywhere anytime soon. It's deprecated, yes, but not obsolete. There's a difference. And so I tell people start OpenGL first because it's a much simpler API, right? And then as soon as you understand the concepts of it and you've written a couple of renders in it and you understand it, then jump to something like Vulkan. I know a lot of people are like, oh, OpenGL is on its way out. OpenGL is not going anywhere, right? Platforms like macOS, yes, have deprecated it, right? You can't use more than 4.1, for example, on OpenGL. But like, that's not even the stuff that I'm talking about learning, right? Like, to learn OpenGL, to get good enough to jump to Vulkan, I'm talking like OpenGL 3.3, right? You don't have to use the most current OpenGL stuff. You want to use it to learn the basics and then move on, right? Because there's a lot less code that you have to write, and there's a lot less things you have to kind of understand to get up and running, because OpenGL abstracts a lot from you. But it is deprecated. It's not going to receive any more updates, right? And so you are going to want to step into those newer graphics APIs, Direct3D, Vulkan, Metal, and you are going to want to understand those things. But I say start with OpenGL first because that is the easiest barrier to entry, right? AI is a horrible teacher mentor. Yeah, exactly. I don't really recommend using it at all, but a lot of folks don't like when I say that, but I have some generally good reasons behind that. Yeah, so as far as OpenGL going anywhere, right? What I think is going to happen, what I think has already started to happen, is the OpenGL API will essentially be a layer that sits on top of Vulkan or Metal or something like that, or Direct3D. I think that's already happening in a lot of drivers, right? So the API itself is not going to go anywhere. It'll still exist. Because if they got rid of OpenGL, you know how many apps they'd break? They'd break 30 years worth of applications and games. You can't do that. If you're on Windows, I'd recommend Direct3D 11. Yeah, that's another one, right? Want to make my small engine for my own games in Raylib. Do you think Raylib is good enough, or should I use bare OpenGL? Depends on what your goals are. If you're wanting to get into game engine development, you need to go bare OpenGL. If you're just worried about shipping a game, then one of those higher level APIs is fine. Right? Depends on what your goals are. In Mac OS, it already sits on top of Metal, I think. Yeah, I'm pretty sure it does. And on Windows, I think it sits on top of DirectX. So it's already happening. OpenGL is a high-level API over Vulkan. That sounds good. Yeah, I think that's already probably happening, right? If you examine the symbols that get loaded when you actually initialize OpenGL, yeah. Raylib is good enough for games, but an engine you will be limited, fighting to do what you want to do. And that's the whole point, right? Like, if you're wanting to build an engine, go raw OpenGL or Vulkan, right? Do not use one of those. Here's the rule of thumb is this, right? If you want ultimate flexibility, do not use somebody else's abstraction of those rendering APIs, right? Make your own, especially if you're learning. If you're past the point in your learning and you don't want to do all that, that's fine. Then, sure, use those abstractions, like this engine here, right? But yeah. Let's see. No, engines save times once you know what it takes. Yeah, exactly. Again, it depends on what your goals are, right? Yeah. There's really no point in using someone else's abstraction. They're not that hard to make and will be tailored to your needs. That's exactly it, right? If you want something general and you're just looking to bang together a quick project for like a game jam or something, then sure, use those things. But again, it depends on what your goals. Use the right tool for the right job, right? Okay. Anyway, I should probably actually write some code. So, okay. So our geometry render data, we had our point light count and our point light indices, right? So get all point lights. I guess probably where I should do this is do static meshes first. So when we're iterating through the lists and we're iterating through our static mesh entities, we're setting up our geometry render data, right? This is where it's going to wind up being added, right? So, you know, we could just do bound point light counts equals, length of the array or whatever it is. This is where we're actually going to hook them up, right? Now, obviously, we'll have to do a little bit of preparation here, right? So each geometry in the material, so for each of these geometries, we'll need to examine where exactly it is in the scene and how it relates to the lights around it. So what we're going to do is, just for the sake of kind of getting this to work right now, I'm just going to essentially put all of the point lights in there. But I'm going to put a fix me in here because we're eventually going to create a bounding volume hierarchy. And we're going to use that to determine where, what lights actually interact with each of these individual geometries, right? We'll sort of, it'll almost be like an interaction table that we'll create, right? So for now, we're just going to use all of them, right, up to, the max amount of 8. So what we're going to do is, we'll say for right now, pick the closest lights that actually, God, I can't spell, interact with this geometry. And add them to the list. For now, this is just adding the closest 8. 8. There we go. Right. So what we'll do is, I guess, let me see. Do we have an I there? So let's do 4. We'll say U8 L. Well, actually, that probably needs to be the U16. So L equals 0. L is less than count, which we don't actually have yet. So let's do U16 point light count. Let's say global point light count, right? And that's going to be DArray length, and that's going to be scene point lights, right? So we're just going to grab all of them for right now, and we'll say we'll take the min between that and the, let's see, max. What was it again? It wasn't this one. This one. Right? We'll take the min between those two so that we don't overflow that, right? And then we'll do global point light counts, and then plus plus L, right? And in here, we'll essentially do like a to-do, distance, check, whatever. For now, we're just gonna, do a straight, completely naive thing just to kind of get some lights in there and see if it works. So what we'll do is, let's see, we probably ought to do this. Let's actually delete this, right? And take this and put it up here. All right, that way we can do rd dot bound point light count, or we'll just do bound point lights sub L, and then I guess we're gonna have to copy over. Let me think about this. We need indices of these, right? So it's really just gonna be L, right? Yeah, that should be fine. And this can actually be U8 now that I think about it. Right? So this is going to be, this should be, instead of bound point lights, we should probably rename this bound point light indices, right? So this is indexed into this array, and also this is going to line up with the other array that we sent over to the renderer already. So we already have that, and then we can actually, instead of doing this, we can do rd bound point light count right here. Okay, and then that's filled out, and we should have everything we need at that point. I believe that should get us what we need on this side. And then on the renderer side, we'll have to pass some of that stuff through. Let's see, you should say you have to wait a few years and then use Kohi. Bad marketing. I know, right? No kidding. In my job, the renderer they use compiles shaders and raw strings in C++. You want to change a value and see what changes. 1 minute compilation every time. Oh, that sounds terrible. Oof. Yeah. Meanwhile, here we have hot reloading shaders. So, yeah, that sounds absolutely terrible, though. All right. So, I think that's all we have to do here. So let's go to the renderer. And we actually have, in our sort of internal scene pass function here that takes all this other stuff, we actually have point light and point light count. So these are the global point lights, right? So we need to pass those through anywhere the scene pass exists, right? So in this case, it's going to be render data, forward data, point light count, and render data, forward data, point lights, right? And we can actually get rid of a comment. Right, so we can actually take this and come down here and do the same thing. And I think there's one more spot. Yeah. Right here. Right. And then in scene pass itself, we will index those lights using the indices that are passed through, right? So we'll have to pass in the indices themselves to the shader, which I think we already have. We just have to actually do it. I think the shader actually is already unpacking them and everything. So material per frame. This is going to be the per draw data. So here's the material instance level stuff. Okay. All right, so we bind. Let's see, these are water planes. I don't want to do it there. Draw geolist is where I'm going to want to look. Although the water planes are going to need this as well. Okay, so bind instance, let's see. Point light count, point light indices. Okay, so here we go. So gather a list of point light indices relevant to this object being drawn. This should be part of its render data provided by the scene, which it is now. So now we're going to have geo bound point light count and geo bound point light indices, right? And this is no longer a to-do. Okay, so that's already hooked up there. I think that's the only place that I have to do it other than the water plane, but we'll come back to that because I don't remember if the water plane actually uses that or not. Let me actually go back. No instance level uniform is to be set. Are we in the... No, that's the debug pass. That's not where I want to be. Let's see. Reflect pass. Okay, so when we actually go to... draw the water planes themselves, that is going to be in scene pass. Here. Let's see. So we bind the base, bind the instance. Here we go. So here's the other part of it. All right. So this is going to be... Oh, I don't think we did this for water data yet. right? Because it should be plain render data. Yeah, it's not there yet. Okay. So we'll do bound point light count, and then we'll do plain render data bound point light indices, right? And we'll just have to add that to this structure here. Right, so it's going to be pretty much the same thing as we have right here, right? So we'll go ahead and put this here. That should solve that error, right? This is no, whoops. This is no longer a to-do, right? I suppose, you know, instead of actually assigning them like this, we could just pass them here as well. Like we could just do plain render data, bound point light count, and then plain render data, bound point light indices. It's probably a little bit cleaner of a way to do it. We can get rid of that. Let me do that and draw a geolist too, actually. It's one less copy operation we have to do. Even though technically it seems a little bit cleaner to do it that way. Oops. Geo bound point light count. Geo bound point light indices, and we can get rid of this. Okay. Back over here in our Illumina scene, we're going to need to do kind of the same thing. So I'm just going to go ahead and do it again the naive way. And I'm going to copy our fix me and our to do. And then in our water plane render data for each one of these things, we're going to do this. Right, so we'll do, what is it, P for all of those. And there we go. All right, so that should be that. Let's see what kind of proper bollocksing we have here. Okay, well I can see the red, so I know it's there. But we still have the sort of, we've still got the issue of, yeah, you can actually see the red in here. So the light works. We still have the issue of the transforms, like not stacking or not doing the thing properly, right? And I think I might know what that actually is. So I think that's in the scene as well. Let me see. Are you doing a depth prepass to prevent too much overdraw and expensive lighting calculation? I'm not yet. That is one of the things that's on my to-do list, is to actually do that first. To use render passes or dynamic rendering? Dynamic rendering. I did away with render passes like a year and a half ago, just because they were annoying. And dynamic rendering is supported on enough hardware where I was okay saying, you know what, if there's like 4 or 5% of machines out there that won't run it, it is what it is. And that number is probably even lower now, to be completely honest. Okay, so I think in our update, we need to do hierarchy graph update. And then we'll do the address of scene hierarchy. I don't think we are doing that anywhere. That might be part of the problem. Sweet. Attempting to free already freed block of memory. Sweet. Where are we doing that? Get rid of those. Dearray destroy. Okay. Destroy view tree node. So we've already freed this for some reason. That's really strange because I've used this before. And I don't think I've modified this anytime recently. So we destroy the child node. Oh, you know what? We don't zero this out, so maybe that's part of the problem. I don't know why it would be, though, but let's adjust that. So we do this. I can't imagine that's the actual entire issue, but it's something that should be fixed. Yeah, I didn't think so. I wonder if this was from my change away from handles. I wonder if that broke something. And I just didn't realize that till now. Yeah, I did eventually change Psycode. Yep. Yeah, I was I used to target a lower Vulkan version, but I kind of gave up on that because the only reason I was really doing it is because I wanted to support mobile. But I kind of tossed that out the window because it was becoming too much of a pain in the butt. And my thought process behind it is mobile Vulkan renderers are so different in how they have to execute that I would probably just write a separate Vulkan backend for mobile that handled it that way. Which I know sounds crazy, but it's that much different. Didn't even want to try using them when I started learning Vulkan a month ago, and they seem so annoying to use. They are annoying. And not actually useful for most hardware, as I understand. Yeah, the concept of a render pass doesn't even exist at the hardware level. So, needing to have a render pass to initialize a pipeline is horrible. That was one of the main complaints I had with it, too. And yes, I had issues abstracting that away 100%. Not on desktop and consoles, at least, yeah. In theory, it could be used for optimizations, but in practice, it wasn't. Yeah, and I did not notice any performance impact switching to using dynamic rendering versus render passes. So, one thing people liked about render passes was the automatic layout transitions, but honestly, you do need to understand it and do it manually in other places. So yeah, not worth it. Yep, 100% agreed. Or just skip Vulkan mobile. Mobile games are all gotchas. Yeah. To be honest, like I've had thoughts of like if I go to support mobile, I might just use GL. Are you saying mobile is off the table for now, or that'll just require a new approach? It's off the table for now, but in the future, like this game that I'm making right now is not going to be on mobile. So for now, I'm not going to be doing it. But in the future, I do want to do it. It's not a top priority right now. Like I've got to, batten down the hatches at some point and kind of scope things a little bit. I already support 3 desktop platforms, right? And I have plans to support like Xbox in the future as well. Support laptop specs from Walmart. That is how you want to program for the people. Yeah, I mean, so one of the things that I have in here is actually going to help with that. One of the to dos I have. 2D engines should target quad and hex core systems unless using no more and less boost mode for software and 2D windowed or mobile games. This will future-proof your projects also. Yeah, but this is a 3D engine, right? So, that stuff's not really going to do me a lot of good. I don't plan on making 2D games with this. If I make 2D games, it'll probably be with a different engine. That's more lightweight than this one. Ambition is a great thing, but only to a certain degree. Yeah, I actually want to finish this project at some point. I actually want to release it. I don't want to just do it for 10 years and then say, well, you know what? I don't feel like doing this anymore. I actually want to take it to market. So if I'm going to do that, I got to start drawing the line somewhere, right? Layout transitions have a pretty solid reason for existing. Yes. You just do them manually. I don't need them done automatically for me. I do them manually. Okay. So, why node children is 4? Let me see what kind of indices into the view nodes array. Okay. I mean, yeah, this is code that I wrote over a year ago, literally. So I don't quite understand why it's broken now. Root count is 6. We are on the second index. Okay. Destroy view node tree. So this is sort of the view that exists internally to allow us to get the hierarchy of objects and stuff. Which should be updatable once per frame. So I'm not 100% sure. Destroy node tree. Let's see. Child of the node. We iterate each of the children. We call this on that. If once it's done with its children, it calls it on. It destroys the array of this for each. Why is that saying it's happening more than once? What am I missing here? Did I do something dingus? I might have. So it's definitely one of the top level nodes. Oh no, it's not actually. It's one level below that. Let's see. So this is a root node. We loop through this, we destroy the child, right? Which the child will also have an array of children nodes, potentially. But it's almost like we somehow manage to include the same index more than once, is what I'm thinking. Let's see. Do you have any form of resource state tracking, i.e. for textures, or do you simply not have the need for that, as you have only a few limited predictable states a resource can be in? I.e., even if you manually transition a texture, how do you keep track of the state it's in? So all of that stuff, well, I guess 90% of that stuff exists in the back end. So I abstract that stuff away from the renderer front end so that the engine doesn't really have to be concerned with it. The only thing that I do, the only call that I have from the front end is basically to say, prepare this texture to either be sampled from or written to, and by calling that, it does a layout transition under the hood, and that's the only thing that I've ever actually needed to do from my application code. So the example of that I always use is the shadow map, right? So you have a phase where you have to write to that shadow map, and then you have a phase where you have to read from it, right? And it needs to be in different layouts for that. But that's really the only place that I use that on a regular basis from the renderer front end or the application, right? Everything else is all abstracted to what I call the renderer backend, or the Vulkan specific backend, right? It doesn't really exist in the renderer front end that the rest of the engine interacts with, except for those two things. Stage and access flags do allow for better explicit synchronization than you get in other APIs, other modern APIs, but still can be quite hard to design properly. Yep. So for the layout transitions, you also need to know the old layout it's in, though, so the back end keeps track of that. Yes, it does. Yep. It keeps track of it where needed. Okay. There's an extension that exists now or is in preparation. If it's available and enabled, then general can be used almost everywhere and be as fast as the optimal layouts. I wonder what the availability would be for that, hardware speaking. Like, how many drivers out there support that? What's the market share support on that? I mean, probably very low at the moment. It doesn't even sound like it's out yet, but yeah, something like that. I would want like 95% market support on that before I would actually use it. Because I haven't heard something like that, but in general, I've always seen, I've always seen that general layout is terrible for performance. If not enough driver supports it, then it's basically useless. Exactly my standpoint on that. Yep. 100% agree. Okay. I don't think I'm going to figure this out in the next 5 minutes. So I think what I'm going to do is I'm going to table this for tonight, because I do actually have to get up in the morning. So we did fix a couple things, which is good. As far as this tree being broken, I'm not sure exactly where it's breaking, so I'm going to have to step through that and see if I can figure it out. But with all that said, I'm going to find somebody to raid. And while I do that, I do want to just say thank you very much to everybody who joined tonight, and everyone who followed along and participated in chat and everything, and followed me on the YouTube side or the Twitch side. I really appreciate those follows. And we're going to be back here tomorrow night around the same time to pick up where we left off. So we're going to raid El's Dragoon because I see that they are still on. They are a team of guys working on an NES game on the actual hardware in 6502 assembly. So I try to raid them whenever I can, and I'm going to go raid them before they raid me. So thank you guys very much for being here. I appreciate you guys, and I will see you guys on the next one. See ya.
good. He read it in. Oh, he is a gentleman and a scholar.
It's like, hey guys, thanks for the stream. We'll be right back.